Okay, so we now move on to part B, and it asks us to use algebra to find where the graphs intersect. So when you want to find out where any two graphs intersect, what we have to get involved with is simultaneous equations. So at the points of intersection, let's just put that as a little intro, at the points of intersection, what I've got to do is solve simultaneously this graph with this one. Now they both have the same y values, okay, so I can literally equate them together. I can say that at the points of intersection these y values will be exactly the same for a given value of x. So I can say that this top graph, x squared bracket x minus 2, let's just write it in, x squared bracket x minus 2 must equal the other values, the other value here. So that's going to be x bracket 6 minus x. So we have an equation in x to solve now. So therefore what we would have, we would multiply this out and we would get x squared times x, which is x cubed, and then x squared times minus 2, which is minus 2x squared, and it would equal 6x, and then x times minus x squared. I'd want to group all my terms that are the same together, and also because this has got a power in it, okay, it's a cubic equation in this instance, I need to bring all the terms onto one side and make it equal to 0. So what I'm going to do is take away 6x and also add x squared to both sides, and that would remove these two terms from this side. It will give me 0. So we start off, we have x cubed, and then I've got minus 2x squared, and remember I'm adding x squared to both sides, so minus 2x squared plus another x squared leaves me with minus x squared. Then I'm subtracting the 6x, so that's minus 6x, and it would leave me with 0. Okay, now we have a cubic equation, and what we should try and do is factorize it. And when we factorize anything, the first thing we should always look for is if the expression that we've got has a common factor. And indeed this equation here does have a common factor. On the left hand side it has got a common factor of x through all of those three terms. So pull out the common factor, so we have x bracket, and then we've got x squared, then minus x and minus 6, and that will equal 0. We can factorize this quadratic factor, so we therefore have the x out the front, a couple of brackets, okay, equals 0, and inside we go an x and an x. Two numbers now multiply together to give minus 6. Go for minus 3 and plus 2, minus 3 and plus 2. Check that they give the minus x. You get minus 3x here, and you get 2x here, so that gives me the minus x that we want in the middle. Okay, so I factorize this now. Next, if we've got a product of factors equaling 0, then any one of these factors could equal 0. So that would lead us to say that therefore x could equal 0, or x minus 3 could equal 0, or the other factor x plus 2 could equal 0. Let's just scroll down a bit more. Okay, so we have obviously x is 0 from that one, or if we add 3 to both sides here, x will equal 3, or, and in this case if we subtract 2 from both sides we get x is minus 2. So 3x values where the graphs cross, 0, 3 and minus 2. Look, we can see them actually. I'll just bring the graph into view again, and you can see that x is 0 at this point, x is 3 at this point, and x is minus 2 at this point here. Okay? But what we're missing is the y coordinates, so we need to find them. So how do we do that? Well, we can substitute obviously x equals 0, 3 and minus 2 into one of the two graphs, okay? The equations for the graph. So we've got a choice of two, haven't we? We've got y equals this one or y equals this one. And looking at the two, I would think that the green one, y equals x bracket 6 minus x, would be the easier one to substitute into. Well, we know that when x is 0, quite clearly y is 0. So we've got that point, okay, where the graphs cross. So let's just, we'll find room down here. Let's just draw a line down here and carry on this side here. So we can just say that when x is 0, okay, y would equal 0. And when we go on to the next x value, x equaling 3, when x equals 3, if we substitute into the green graph, we get that y equals the value x, which is 3, times 6 minus 3. Well, 6 minus 3 is 3, and 3 3s are 9, so therefore we have y equaling 9. And finally, when x equals minus 2, and we put that into the green graph, we get that y equals the x value, which is minus 2, times 6 minus minus 2. Well, 6 minus minus 2 is 8, and 8 times minus 2 is minus 16, so therefore y equals minus 16. Well, they're my answers where the graphs intersect, but I could just summarize by just saying graphs intersect, okay, at, and we'll just list those coordinates off. I'll go from left to right. So this point here is at -2 minus 16, the answer I got down here. Then the next point is the origin, 0, 0. And the last point is this point here, oops, sorry, this point up here, and that point is at 3, 9. Okay, 3, 9. So I hope you're able to follow that, and be good if you got it right, and well done if you did. If not, I hope you've been able to follow though what I've done so far.